Recurrent neural networks, RNNs, are a type of artificial neural network, RNN, which are designed to identify patterns in a given set of data and then create output based on the identified patterns. This type of network is particularly well suited for tasks such as sequence analysis and time series analysis due to its ability to capture patterns and then use them to predict future outputs. This is enabled through the use of a recurrent structure which enables the network to store information from previous inputs in order to better inform the output of future ones. RNNs are comprised of a set of neurons, input layers, and output layers. The neurons act as connections between the input and output layers and pass signals along the network. Unlike a traditional ANN, the neurons in an RNN are designed to send and receive signals in a loop structure and are arranged in such a way that when a signal is received from an input layer, it is then relayed and sent back to the input layer again with slight variations. This enables the network to store information from one input to the next and further inform its outputs and predictions. Alternatively, the neurons in an RNN can also be arranged in a more unrolled fashion, allowing for a more detailed analysis and prediction of data in a given time frame. Each time step then receives its own inputs, meaning the number of layers increases with all given inputs, allowing for even more complex analysis of the data. Like all ANNs, RNNs are trained on a given set of data, typically in a supervised fashion. This involves inputting data into the network and then adjusting the weights or connections in the neurons until desired outcomes are achieved. Once trained, the RNN is able to take the given patterns and data it identified as a part of its training and then use them to inform its outputs and predictions. RNNs are commonly used in a variety of tasks. One of the most common applications involve natural language processing, NLP, or the ability to identify natural language inputs and then analyze and understand them. Another common application involves analyzing time series data such as stock prices, weather conditions, or other variables which have the potential to form a pattern. Overall, RNNs are a powerful tool in data analysis due to their ability to capture patterns across multiple steps, allowing for more complex analysis of data at both local and global levels. Although not without its challenges such as the vanishing/exploding gradient problem and training time, when used in the right manner, RNNs can aid in efficient data analysis and output prediction.